Welcome to Homework Lib.
Hi, so in this question we're going to mix the same volumes, that is 50 milliliters of each 3 molar HCl and 3 molar sodium hydroxide, which is going to amount to a 100 milliliter solution that is going to have an initial temperature of 20 degrees Celsius, a final temperature equal to 40 degrees Celsius, and we're told that the heat capacity of the calorimeter is equal to 0. And the enthalpy change for the reaction needs to be found. This needs to be written in kilojoules per mole. Other information that is given to us is that we can approximate the density of the solutions as being as 1 gram per milliliter, and that the heat capacity of the solution can be approximated to that of water, that is 4.18 joules per gram degree Celsius. So over here, remember that the heat that is going to be released or absorbed can be calculated employing mass times heat capacity times delta T. In this case, the mass is equal to 100 milliliters multiplied by density, that is 1 gram per milliliter. So the mass is going to be equal to 100 grams. The heat capacity is given, and the change of temperature, delta T, is equal to final temperature minus initial temperature, which is going to be equal to 20 degrees Celsius. So the heat that is released by this whole reaction is going to be equal to 100 grams times heat capacity, 4.18 joules per gram degree Celsius, times delta T, that is 20 degrees Celsius. The result of the heat release is 8,360 joules. So now we need to divide by the amount of mole that we employed. In both of the cases, the reaction, regardless of what happens, I'm going to write down the reaction as it was, like the molecular reaction instead of the ionic one. What we're going to generate is a salt plus water, right? So the amount of mole that we add of each of them is going to be giving us the amount of mole for the reaction. In this case, we have 50 milliliters, which is equal to 50 times 10 to the minus 3 liters. And remember that molarity is equal to amount of mole divided by volume. Thus, the amount of mole would be equal to molarity times volume. The amount of mole that we had added of each of the reactants, in this case, would be 50 times 10 to the minus 3 liters, multiplied by 3 molar, which is 0.15 mole. So the result for delta H is going to be equal to the heat release divided by the amount of mole. So the heat release, we said that was equal to 8,360 joules. This is released by 0.15 mole. Let me go down a little bit here. 0.15 mole. So we get 55,733.33 joules per mole, which is equal to, of course, in this case, since the temperature increased, the delta H needs to be negative. So let's put the negative on both over here. So the delta H is going to be 55.7 kilojoules per mole, which is the third answer in your question. So thank you very much. Sorry, the last one. Be careful with joules and kilojoules. So minus 55.7 kilojoules per mole. Thank you very much and have a good one.